Today we are going to talk about what are some common reasons people give when they suggest that you should not become a data scientist in 2025. And I'll share my take on those objections based on my 10 plus years of experience working as a data scientist in the US tech industry. And these are the three most common objections people have against becoming a data scientist. And I'll share my take on these one by one. So starting with this first one, that data science jobs are going to be automated anyway. So there is no point in becoming a data scientist because ChatGPT and Google Gemini, they can already write the code. And that would mean that people who are already working as a data scientist will start losing their jobs. And of course, that would mean that any newcomer won't have any job left because most of the things will be automated through AI. I hear this objection a lot of time, and it looks like a very valid concern because I use Google Gemini and ChatGPT on a day-to-day basis in my job, and I'm sometimes impressed by their ability to write code, by their ability to provide solutions and suggestions in a lot of times. But still, their total ability to write code, to provide suggestions, to understand business context, it is nowhere near in comparison to what a human can do. I think a very important thing to look at is the recent news that Meta had some massive layoffs recently. This is not the first time company had let go thousands of people. In the last 2 years alone, they had fired 11,000 people, then 10,000 people. Then there were some smaller layoffs, and recently they have let go about 5% of their workforce in a single day. 3,600 people to be exact. And what is interesting in this article is that Meta said that they will be replacing these employees with machine learning engineers. Now, machine learning engineers are basically advanced data scientists. This is a topic which I've covered in detail in another video, but in a nutshell, this is what the job description looks like for different data-related roles. And as you can see, that machine learning engineer and data scientists have a lot of overlap. It's just that the machine learning engineers focus more on model development and model deployment. So it is basically an advanced tier of data scientists. That's how I usually explain it. But coming back to this news of Meta laying off thousands of people and saying that they are going to take all that money, which they will be saving from these layoffs, and they will be investing in hiring machine learning engineers, gives a very clear sense that if companies like Meta, who have the best AI technology available, one of the best open source LLM is from Meta, Llama 3. So if company like Meta, who have a ton of good AI engineers, are not thinking that the data science job will be eliminated, and instead they are hiring a lot of machine learning engineers recently. So this can give you a sense of how some bigger companies are thinking in terms of what the future of data science and machine learning is. And what jumps up from this news article is that these companies are thinking that they would be needing a lot more data scientists and machine learning engineers and not less. Another thing which I wanted to share with you to further emphasize my point is this chart from TrueUp. This tracks the number of open jobs from different categories, and for AI ML specifically, we can see that this graph is continuously going in an upward direction. Despite us seeing a lot of layoffs and also overall decrease in the number of open positions, this trend clearly indicates that companies are investing more money into hiring AI, ML, and data science talent. Now, this does not necessarily mean that if you are applying for some of these roles, you'll have an easy chance, because what we are seeing here is that a lot of companies are pivoting towards AI ML, and it is also true on the demand side, and it is also true on the supply side, because a lot of newcomers are also trying to learn data science, AI ML, and compete for these positions. So not only there is demand from the company side, they want to hire more talent, there is a lot of demand from the supply side, because a lot of people want to become a data scientist and machine learning and AI engineers. So as a candidate, you might still get a hard time trying to land one of these roles, but the underlying fact that companies are opening more jobs for these positions indicate that companies have confidence that they need more humans to be in the workforce so that they can help them solve some business problems. And the last thing which I want to say about this objection is that, let's say if data science you think is going to be automated, and you want to not become a data scientist this year or the next year, my question to you then would be, then where would you go? Because every single job will have some AI impact. AI is everywhere. It will impact the jobs of doctors, engineers, lawyers, pharmacists, you name a profession, and I can tell you hundreds of ways AI is going to impact that profession in the years to come. So even if we agree that a big part of what data scientists do is going to be automated, I still think this is still the safest place in the years to come, because as an AI engineer, as a data scientist, as a machine learning engineer, you would be part of that automation and you would be part of that innovation, which will be impacting every other job in the world. So now let's look at the next common objection, which is that tech jobs generally do not have a lot of future. And this is a very common sentiment nowadays. We are seeing that a lot of companies are having some massive layoffs, including the example of Meta, which I gave. This is a chart again from TrueUp, and here they are tracking that how many people have been impacted. So this tracks that how many people from the tech industry were laid off in every single year. So we can see that it started in the year 2022. We had about 243,000 people who were let go in that year. And one thing which is interesting to note here is that the massive layoffs, this started in the last 3 months of this year, 2022. So the big bar which you are seeing, it mostly happened just in the last 3 months, October, November, December of 2022. And then we have 2023, probably the worst year for the tech industry. Massive layoffs, about 430,000 people were let go in that single year. Every single company, they were firing people. Two of the companies I have worked in, Meta, 10,000 people were laid off in 2023 and 11,000 people were laid off in November of 2022. And Cisco also had some massive layoffs in 2024 where they let go about 12,000 people in 2 different job cuts. So we can see that 2022, 2023 and 2024, they were not very good years for the tech industry because of these massive layoffs. Another thing which we are noticing is that right now, because there are so many people into the job market and very few positions available, there is just so much competition for every single job which gets posted. These are some screenshots of some extreme examples. Most of the jobs do not have this kind of scenario, but we can see that this machine learning engineer job, it has 1,423 applicants. Same here for data science job, 3,840 applicants. Again, this data science job, and we can see 4,000 plus job applicants for this single job. So of course, when someone looks at these statistics, one conclusion which is very easy to come to someone's mind is that tech industry overall is a sinking boat, and it makes no sense that when it is starting to sink that you jump into this ship. But before you draw that conclusion, let me share slightly different opinion with you. So going back to this chart of layoffs, one thing which is important to see here is that the 22 and 23 of course were very difficult years for the tech industry because of all these layoffs. But when we look at 2024, there are 2 things which we have to keep in mind. First, that these layoffs of 2024, it is still significantly lower in comparison to 2023. And the other thing which we have to keep in mind, that it is slightly higher than the same baseline we had in the year 2020. So companies naturally, even before, used to let go of people and they would hire a lot of new people. So layoffs is not a new phenomenon. It's just that when it went off the roof in the end of 2022 and 2023, that is when it was concerning. But what we are seeing is a downward trend in the layoffs, and it is going more towards the normal layoff scenario which we had seen in 2020 and the years before, when these tech layoffs was not something which was top of mind for everyone. The other thing I want to show you here is that this is a chart from Federal Reserve Bank, and what we are seeing here is that what are the number of open jobs available, and it started from Feb 2020, and then it is tracking that in comparison to February 2020, how the job market is doing. As we can see that there is this big spike happening in the year 2022, and then currently we are at a very low level. Now, if we compare it against this benchmark of February 2020, then we can see that we are at about 34.1% 35% drop. And this basically means that currently there are 34% or about 35% less jobs available as compared to our previous baseline, which was February of 2020. The reason this was taken as the baseline is that this is what was the situation before COVID. So definitely the number of open jobs are much less than before, but tech is still one of the best career options right now. Let's look at some other numbers. So this is a comparison of tech jobs in the US compared to overall US job market. We can see that the average salary still is about double than the average of overall US job market. We can also see that this is the expected future growth in the next 10 years. According to Bureau of Labor and Statistics, tech industry is expected to grow at 25% growth compared to just 4% growth of the US job market overall. Now, a couple of things I wanted to say about this number is that in the previous 10-year window, which was 2014 to 2024, the US job market was expected to grow at 13%. And in the next 10 years, this number is much lower. They are expecting the US jobs overall to grow at a 4% level. But still, the expectation for the tech job market is pretty good. So it is at about 25%, much better. The job satisfaction, regardless of which survey you look at, it is much higher as compared to the overall job satisfaction. And the main reasons are higher salary, the work-life balance. A lot of jobs are still remote, or they are in hybrid, so you have to go in the office 1 to 2 days a week. And tech companies still generally offer a very good benefits in terms of health insurance, 401k plans, and the parental leaves. And the last thing, which is a little troublesome, is that the unemployment rate currently in the tech is much higher as compared to the overall unemployment rate. And this is because of all the layoffs which I've spoken previously about. So let's look at where we are going into the future and what does the future look like. Most of the layoffs which we have seen is because of the overhiring which happened here. You can see that all of the sudden the tech jobs, if 100 is the base benchmark, went all the way to about 240. So tech jobs in a single year doubled, actually more than doubled, and that led to a lot of hiring. And when the company hired so many people because the interest rates were low, money was cheap, and everyone had their wallets full, they went into hiring spree and everyone was getting hired. But when the federal bank started increasing the interest rates, the money became tight, and then the companies realized that they have overhired a lot of people, which they had to let go. And that led to two things. One, they had to fire a lot of people which they have hired. And the second thing was there was not as much new demand of hiring a lot of people because companies had already hired so many people. And just to highlight the importance of tech industry, this is the picture I wanted to share with you. So this is at the inaugural ceremony of the new president of the United States, Donald Trump. And when you look at this picture, one thing which very clearly stands out is that in the front row, most of the faces you see, these are tech CEOs. You can see Mark Zuckerberg, you can see Jeff Bezos, Elon Musk, Google CEO Sundar Pichai, and a lot of other people. And the reason I think this is a very important picture is that this tells you that where the world is going and what the world thinks is the future. Tech is not the only important sector in the US. There is energy sector, very big. There is healthcare sector, very big. There is a banking sector, very big. But everyone realizes that tech is the future. And that is why in the front row you see so many tech billionaires. Another important statistics I wanted to show you is that this is the tech companies' share in the S&P 500. Now, S&P 500 is basically a list of top 500 companies in the US, and the composition of that top 500 company changes over time. But we can see in 2005, out of those 500 companies, about 18% were from the tech industry. And then 10 years later, in 2015, we saw that this number grew to about 22%. And today, in 2025, this number is about 33%. And as you can see, that more and more bigger companies in the overall 500 companies list are becoming tech companies. All of this is a very long way to say that tech still has a very bright and important future. And I see no reason that this importance and dominance of tech is going to decrease in the future, because every single thing we use today is going to become digital in the future. And we need people who develop those solutions, who maintain those, who troubleshoot those, and who help other people use that too. And these are all tech people. So I think tech overall has a very bright and tremendous future ahead. Now, coming to the third objection, which is that data science is very math heavy and you need to know a lot of math and you need to have a PhD to get into it. I want to share some quick thoughts on that and also acknowledge that where does this concern come from. So this is just a screenshot from one university's lecture where they were trying to teach the very first and the fundamental machine learning concept, which is linear regression. And as you can see that as a person who does not have a lot of math knowledge or who is scared of mathematics, when you look at this looks definitely very scary because there is just so much math into it, and everything which is taught through the lens of math. And of course, if you do not know math, then there is no way you could understand what's being shown here. And this is just the very first foundational machine learning model, which is linear regression. As you go into decision trees and as you go into ensemble trees and as you go into neural networks, of course, the math and the complexity of it is going to increase a lot. But what I've seen per my experience is that, so though machine learning, it stands on the foundation of math, every algorithm basically has a mathematical formula and derivation behind it. But things are becoming more and more conceptual, and there is a lot more abstraction on top of it, so that even if you don't know math, you can still do a very good job as a data scientist. Let me quickly explain what do I mean. So this is how you would write the code for linear regression if some advanced libraries were not available. Around year 2010, 15 years back, if you have to write the code for linear regression, this is how you would write it in Python using NumPy. And as you can see that there is a lot of exception handling which you would have to do if you are writing the good code. And also there is a lot of optimization. You need to know a lot of math to be able to write some good code here. One thing I want to quickly highlight, which might not be obvious to you, is that here we are using a dot product between two metrics. And this is a very intelligent way of writing code, because the most obvious way to write a code, which is if someone doesn't know a lot of math and would try to write this code, they would have a for loop here. And for loop could be 40 to 50 times slower as compared to a dot product. So if you don't know a lot of math, you would try to implement and write the code 15 years ago, you would write a for loop here. And that would mean that if you have to run your code against thousands of rows, and with this code, it takes 5 minutes to run, that code, which you would write with the for loop, would take more than an hour to run, maybe 5 hours to run. So you would need to know a lot of math and be very good at programming to be able to write even linear regression 15 years back. But see how things have changed over time. After this, we had scikit-learn. And in scikit-learn, you can write this same code, which is much, much faster, is very good exception handling in just these 3 lines of code. And to be able to write these 3 lines, you don't need to know any math, honestly. And now things have even further evolved in the last 2 years. So this is a screenshot of Google Colab. And there I have just asked it, hey, write a linear regression code to use X to predict Y. And it has written all the code for me. So I don't even need to remember and know how to write these 3 lines, because now I can pass on the instruction in a human natural way and the machine will write the code for me. Now, I'm not saying that you do not need to know any math and you do not need to know any programming and you can just pass on these instructions in a human readable way and the machine will write the code for you. That is still not true. What I'm trying to say is that developing intuition around how does different concepts work, what is the underlying intuition behind, without going into the fancy math and the mathematical equations and derivations, if you could understand what is the intuition behind every formula, every machine learning algorithm you are using, you would be in a much, much better shape. I have created a whole series on my YouTube channel where I have explained some of the most fundamental and most frequently used machine learning algorithms without mentioning a single line of mathematics. And there I have tried to explain it in a very intuitive way so that you could develop the intuition behind how does linear regression work, how does decision tree work, and a lot of other algorithms without even knowing a single math. So if you have that intuition and you have some good foundation into programming, then you would be a very good data scientist, even with no fancy math degree. And when you look at the profiles of a lot of data scientists, one thing which would jump out to you is that people do not have very fancy mathematical backgrounds. I was not an expert at math when I started. Now, you would need to know some statistics and you would need to know some basic foundations of these machine learning algorithms. And that I think anyone with the right attitude can learn. It's not a rocket science. A lot of people, maybe thousands of people, have learned it before you. And when they started, they had zero knowledge about it. So if they can learn, you can learn it too. So I think it is difficult, and difficult is actually good because that would mean that you know something which not a lot of people would be able to learn. But it's not impossible. It's not rocket science. And with the right attitude, with the right guidance, you can definitely do it. If you want to have a look at the series I mentioned where I have gone through most of these important and popular machine learning algorithms in a very intuitive and easy to understand way, here is the link for that. Please check it out. I'm pretty sure you'll like it. Thank you so much for watching.